Okay, in this video we're going to discuss what is called the natural log. So a lot of times you'll just see ln of x. ln is what is called natural log, and it is log base e of x. So we called e our natural exponent or natural exponential function. And if that is your base for the log, then you have what is called natural log, ln of x. If we want to evaluate the natural log, I'm often just going to think about it in this form so that we can understand what we're looking for. Again, we are looking for what is the exponent that we would put on e to get that thing on the inside. So the natural log of 1, what I would say to myself is e to what power is equal to 1. And again, anything at all to the 0 power is going to be 1, so the answer there is 0. Here I would have e to what power is equal to e. That's going to be e to the first. Here we have e to what power is equal to e to the 8th. That means we're going to get 8. So anytime you have natural log of e to a power, your answer is going to be that exponent. So the same thing occurs on number 4. We get 54 as our answer. Number 5, we have e to what power equals 1 over e squared. Well, the 1 over, it happens because there was a negative exponent, so the answer here is negative 2. E to the negative second power would give us 1 over e squared, so the natural log of 1 over e squared is going to be negative 2. And then number 6, the natural log of 5. So this is saying e to what power is equal to 5. The answer is not 5, okay, because it's not e to the 5th here, it's just 5. So there's really no shortcut here, and I don't know what this number would be, so if we plug that into a calculator and just do the natural log of 5, you see that we do not get a nice answer here. It's just 1.609. 1.609. Again, not a nice answer there, but that's all we're doing there. We're looking at e to what power would give us the stuff on the inside. Okay. Next up in here is just talking about the domain of logarithmic functions. So not even just natural log, but the same is true for natural log. But any logarithmic function, how do we find the domain? And if we think about the graph of a logarithm, remember there is a vertical asymptote at the y-axis, or at x equals 0. So what we're going to do is we need to understand that the stuff inside the log cannot be evaluated at 0 or at any negative number. So we are going to take what is inside the logarithm, which in this case is x minus 4, and we are going to make sure that that is strictly greater than 0. Again, because there's a vertical asymptote at 0, we can't equal 0. We also can't be to the left of 0. So x minus 4 has to be greater than 0, so x in this case would have to be greater than 4. Here we would have 4 minus x squared needs to be greater than 0. Now this is a little bit tricky because we have a quadratic here. So 4 minus x squared being greater than 0, what you would want to think about here is what would make that 0, and that would be negative 2 and 2, right? If I actually solved that, you just got to be careful there because the tendency would just probably be to say that x has to be greater than 2 if you solved this. But if I said equals 0 for this instead and I factored this and solved it, I would see that we would have negative 2 and 2 there. And then we need to think about plugging things in to the left, or plugging things in each interval. So if I did something less than negative 2, like negative 3, I would actually get a negative answer here. If I plugged in something between negative 2 and 2, like 0, I would get a positive. Again, I'm plugging them into here. If I plugged in something like 0, I'd get a positive number there. If I plug in something to the right of 2, like 3, I would have 4 minus 9, which again would be negative. And so I want to know when is it greater than 0, which only happens here. So the domain for this would be between negative 2 and 2 in interval notation here. It's a little bit tricky with a quadratic, but you need to think about this quadratic inequality stuff that I think you've seen before. Same thing is true for number 3. Again, we have a quadratic. X squared minus 9 would have to be greater than 0. And then we want to again, think about this as if it were an equation. So if we factored this out to x plus 3 and x minus 3, we would think about on the number line having negative 3 and positive 3 here. And then plugging in numbers into this or into this, however you want to look at it, in each one of those intervals. Okay, so if I plug in negative 4, I would get a positive value in this case. Negative 4 squared would be 16 minus 9, so positive 7. If I plug in something between negative 3 and 3 like 0, 0 squared minus 9 is a negative number. If I plug in something to the right of 3 like 4, again, 4 squared minus 9 is going to be a positive number. So in this case, again, I want to know when is it positive, when is it greater than 0, which happens here and here. So that would be negative infinity to negative 3, and also from 3 to infinity. The main point here, okay, the main point is that when you're doing domain of a log, you are taking the stuff on the inside and setting it greater than 0 and then solving. Okay, sometimes it'll be quadratic, which is a little bit more complicated, but if it's just a linear expression in there, it's pretty easy to solve. So natural log is log base e. Domain, take the inside part and set that greater than 0 and solve.